Okay, in this video we're going to take a look at basically using the Haxall Xeto toolkit as a Java library. So just to recap, Haxall is the open source implementation of Xeto. It's written in the Phantom programming language, which lets us use it both with Java code or with JavaScript and TypeScript code. In this video, we're going to specifically be looking at how to use the toolkit in Java by using this tool we've developed called fanc, which will transpile the Phantom to Java source code. So the first thing we're going to look at is this new fanc tool. And I'm basically pulling everything from source here in terms of the Haxall and Phantom repos. So basically, you can see here I can transpile Phantom pods to either Java or JavaScript. In this video, we're going to look at the Java. And we can see it's got a bunch of options here. So basically what it does is it's going to take a list of pods and transpile them to Java source code. So we're going to actually generate a jar file called xeto.jar. Okay, we're also going to generate some Java doc. And we're going to generate this from the Xeto C pod and also this pod I have called play. And we're going to do preview so we can see exactly what's going to happen here. So basically what it's going to do is it's going to figure out the dependency chain of Xeto C, which is going to include all of these pods, which is our concurrency framework, the full haystack toolkit in terms of the grids, dictionaries, trio, zinc, etc., as well as the Xeto compiler and the implementation code. And it's going to generate this jar file in this location. It's also going to generate my Java doc. So when I go ahead and kick this off, this is going to basically do that transpile. It's going to run Java C and build my jar file. Let's take a look at I'm going to look at a little bit of Phantom code here. So basically, I just want to show this class foo. Okay, he's got a method that takes a default, and he's got basically another method that returns a list, and he's got a const field, and he's got a mutable field. I also have this program here, which is going to show you the very basics of using the Xeto library. So I'm going to create I'm going to look up my local repository here and create a namespace. This will solve my dependency chain and create a namespace. Here I'm going to iterate the libraries in that namespace using the namespace.libs. And then I'm also going to look up a spec and dump his slots. Let's take a look at what this generated in terms of Java code. So the Java library is going to be all my Phantom pods are going to be fan.pod name. Okay, so here we can see in that play class that got generated. So I have my my foo class I generated. We're going to look at what that generated. Anything with a $sign is going to be synthetic and should not be considered part of the public API. But we can also see how these methods got generated here. So here I had a very simple method M1, and then I had a default parameter. So I'll generate one version that will set the default parameter and another version that takes that parameter. We can see M2 is generating a list of foo, and that's going to basically be a parameterized list. Now, a Phantom list will implement a java.util.list, and Phantom map implements java.util.map also. In terms of my const field, you're going to see that's just a getter. And in terms of my mutable field, you're going to see that returns the field, or I have another version that is basically the setter. Let's take a look at the code that generated the repository access. You can look at this and see that this generated the Java code that will read from that repository. Now notice we're basically using qualified names here. You probably wouldn't do that in your code, but the transpiler is going to generate accurate code here. And then I'm iterating basically the libraries here using a closure, and then I'm iterating the spec using a closure. So obviously if you were writing this in hand by Java, it would look a little different, but you can look at how this is generating in Java. One thing I do want to mention here in terms of the output is, so your source code is going to go in this Java. This is fanx is like supporting code, and then you have this fan per pod that you generated. And then your output, if you want to jar it, you do need extra stuff. So here basically the reflect is all the information we need for reflection in Phantom, and then the resources is basically any sort of resource files we need for the Phantom runtime. So for example, the time zone database, unit database is all packaged up. And then this becomes your jar. So this xeto.jar basically includes the entire Phantom runtime as well as the libraries we specified for Xeto. Now if we want to run that, we basically can put that jar file in my class path, which is the xeto.jar, and I can run, first of all, let's run the main I created, which was play.main, And you can see basically that's going to, as we wrote, we're going to dump the libraries, and then we're going to look up that spec and dump it. We can also basically got the whole basic command line in here for Xeto. So basically this is fan.xeto.main, and you, for example, you can dump the repository. Here we're basically, if we dump the version, we can see we're using the Xeto.props pathing mechanism as described in the markdown and in the GitHub. Or we can actually run a build here, and you can see we've got the full compiler here running the build. One last thing I just want to take a look at is the Java docs here. So you can see I actually generated Java docs, and you can see all of those fan classes as they look like in Java. Okay.